So imagine we have a function f of x equals x squared minus 6x plus 5, and we're asked to optimize this function. So how do we go about that? Firstly, we need to first understand what optimization is. So whenever you're asked to optimize a function, you are basically required to find the maximum or the minimum value of that function. So how exactly do we find that? The first thing we need to do when finding the maximum or minimum value of a function, we first need to find the critical points. The critical points are basically the points on the graph or on the curve. When you graph out a function like this, you're going to have a curve, a curve that mimics this setting. Either something like this or something like this. Depending on the function, it could be steeper, it could be, it could be wider, it could be slimmer, but this is basically how the function will look like when you graph it. So the critical point is basically the point on that curve where the gradient or the slope is equal to zero. Basically the flat point, like this point here. This is the flat point. So it is at this point that you get your critical point, basically when the gradient is equal to zero. So when you do that, so in fact, let's just demonstrate that. Let's say we have a function f of x equals x squared minus 6x plus 5, and we want to maximize or minimize this function. We basically want to optimize this function. The first thing we need to do is we need to find our first derivative. So f prime of x, that's the notation for our first derivative, is going to equal 2x minus 6 from a power rule. Then the next step is to set this derivative to equal to 0. Basically the derivative basically tells you how y changes with respect to x. That's basically slope or gradient, if you've been following my videos. So you need to set this to equal 0. So we now have 2x minus 6 is equal to 0. So take this to the other side. So we have 2x is equal to 6. Divide both sides by 2. Divide both sides by 2. This cancels this. So x is equal to 3. What we basically did here is basically found the point where the slope of the function is equal to 0, which means the part of the curve or the point on the curve where the derivative or this gradient is equal to 0. That's the flat point here. So we basically differentiated the function to find the derivative, and we set it to equal to 0, meaning we set the derivative to equal 0 as the change to equal 0. Then at that point where the derivative is equal to 0, we have a fine gentleman there as x is equal to 0, x is equal to 3. So this point, x equals 3, is called the critical point. That is a point at the point of a curve where that curve's gradient is equal to 0. It's basically this is basically the value of x at the flat point. So now that we found our first derivative, we now need to determine if this point is a maximum or a minimum point. How do we do that? The rule says f double prime of a, where a is the value of x, if it is greater than 0, then it is the minimum point. Then if f double prime of a is less than 0, it is the maximum point. Now how do we get f double prime of a? We basically take the second derivative of the function. So we have our first derivative to be 2x minus 6. The second derivative is just going to be f double prime of x, is just going to be 2. So this is our second derivative. Now we need to evaluate f double prime of a. Remember, our a is equal to 3. That's the value of x at the critical point or at the flat point of the curve. So f double prime of 3 is equal to 2. Or no, do not have any way we can plug the 3. So our f double prime of 3 is just equal to 2. So remember the rule: if f double prime of a is greater than 0, it is the minimum point. So 2 is obviously greater than 0. That means f double prime, that means 3 is our relative minimum. That is the minimum point at the flat curve, at the flat point of the curve. So now how do we get the minimum value of this function? Since we already established that x equals 3 is the minimum point or a relative minimum, we need to now optimize this function with this value. When we plug in x equals 3 into the original function, we get the minimum value of the function. Why? Because this x equals 3 is the relative minimum or the minimum point on the function. Do you understand? So let's plug it back into our original function. So we have something like 3 squared minus 6 times 3 plus 5. So f of 3 is equal to 9 minus 18 plus 5. 9 plus 5, that's equal to 14 minus 18, that's equal to minus 4. So the minimum value of this function at the minimum point of 3 is equal to minus 4. So let's take another example. Let's say we have something like g of x is equal to x cubed minus 3x squared plus 2. And we're asked to optimize this function. So the first thing we need to do is we need to find our first derivative of the function. So that's g prime of x is equal to 3x squared minus 6x. Then derivative of the constant is 0. Then we need to set that derivative to equal 0 to get our critical point. That's the point at which the slope of the curve or the slope of the function is equal to 0. So we need to set g of x to equal 0. That will be 3x squared minus 6x is equal to 0. So what we can do, we can factor out a 3. So we have 3 open brackets, x squared minus 2. Minus 2 is equal to 0. Yeah. 2x. So our function is just going to be x squared minus 2x is equal to 0. Sorry, my bad. So we can factor out an x2. So we can factor out x, then we have x squared minus 2 is equal to 0. So we have x rather minus 2 is equal to 0. So our values are x equals 0 and x minus 2 equals 0. So our critical points are x equals 0 and x equals 2. So these are our candidates. So at the flat point of the curve, x is equal to 0 and x is also equal to 2. So we need to determine if these points are maximum or minimum points, or relative maximas or relative minima. And how do we do that? Remember the second derivative test. So we need to find second derivative of our function. The first derivative of our function as g prime of x is equal to 3x squared minus 6x. We already established that. So we need to differentiate this again to get our second derivative. So g double prime of x is going to be 6x minus 6, right? So now we need to plug in our values of 0 and 2 into this function to determine whether these points are maximum or minimum points. Let's try with 0. So g double prime of 0 is equal to 6 open bracket 0 minus 6. So g double prime of 0 is just going to be 6 times 0 is 0 minus 6. So g double prime of 0 is equal to minus 6. So that means 0 is a maximum point since it is negative. So how do we determine? Let's determine if x equals 2 is a maximum or minimum point 2. So let's check. So we know that our g double prime of x is equal to 3x squared minus 6x, right? So g double prime of 2. Oh, sorry, I'm supposed to use second derivative here. My bad. The g double prime of x is 6x minus 6. So g double prime of 2, just evaluate the second derivative at x equals 2. So that's going to be 6, 2 minus 6. So g double prime of 2 is going to be 12 minus 6. G double prime of 2 is equal to 2. That means 2 is a minimum point based on the rule. So since we have maximum and minimum points respectively, we can determine the maximum and minimum value of the original function. So we have our g of x to equal x cubed minus 3x squared plus 2. That means the maximum value of this function that will be evaluating the function at x equals 0 is going to be 0 raised to the power 3 minus 3 open bracket 0 squared plus 2. That means g of 0 is going to be 0 minus 0 plus 2. That means the maximum value of this function is just going to be 2. So now we can evaluate the minimum value of the function by evaluating the function at x equals 2. That's the relative minimum point. So g of 2 is just going to be 2 raised to the power 3 minus 3 times 2 squared plus 2. Minus g of 2 is going to be 2 raised to the power 3 is 8. The minus 2 squared is 4 times 3, that's 12, then plus 2. So g of 2 equals to is 10 minus 12, that's minus 2. That means the minimum point of this function is just minus 2. So that's basically it. Let's take another example. Right, so we have a question. We have a profit function, pi of q is equal to 50q minus q squared minus 100. I'm asked to maximize profit. Yeah, and I'm asked to maximize the profit. So one thing to notice is whenever you are given a function to optimize and you're told to maximize or minimize that function, that means you need to know that you don't even need to do the second derivative test, because that implies that the critical point is a maximum point, or if you actually to minimize that function, that means that the critical point at that function is a minimum point. So you do not need to do the second derivative test. So here we're asked to maximize our profit function. That means the critical point of this function is a maximum point, so we do not need to do the second derivative test. So the first thing we need to do to maximize our function, we first need to find our critical point, which is in turn the maximum point. So to do that, we first find our first derivative and we set it to 0. So pi complement of q is going to equal 50 minus 2q, then the derivative of minus 100 is just 0. So then we need to set this pi of q to equal 0. So that's just going to be 50 minus 2q is equal to 0. So we have 50 is equal to 2q. Divide both sides by 2. 2 cancels this. So q is equal to 25. So this is our maximum, our critical point. That's on this curve. If you draw it on the graph, the flat point, the value of q at that flat point is 25, and also we are maximizing the profit. That means this point is also a maximum point, since the question told us to maximize profit. When you are told to maximize or minimize a function, that are implicitly telling you that whatever critical point you get is automatically the maximum or minimum point depending on the question. So now we can plug in this q equals 25, which is our maximum point, into the original function to get the maximum value of this function, which is in turn the maximum value of the profit. So pi of 25 is just going to equal 50 times 25 minus 25 squared minus 100. So that's going to equal 50 um, times 20. That's just going to give us 1000. Then 50 times 5, that is 250. So we have 1250 here. Minus 25 squared, just 625, and minus 100. So pi is just going to be 1250 minus 725. So the maximum value of the profit is just going to be 1000 minus 700, that's 300. Then that's 300 plus 250, we have 550. 550 minus 25, that's going to be 525. So the maximum value of this function, or the maximum profit that the firm can make, this is the firm's profit function, it's 525. Let's say this is in naira, so 525 naira. So yeah, that's that for the function. So let's take one last example. So we have a cost function, c of q is equal to q cubed minus 6q squared plus 15q plus 20. And we're asked to minimize the firm's cost. So remember, the first thing we need to do is we need to take our first derivative and set it to 0 to find our critical point. That's the point at the flat curve, at the flat point of the curve. Because every function, every exponential function, when they are drafted, will have a curve. They will manifest in form of a curve. So we have c prime of q is equal to 3q squared minus 12q, then plus 15, because the derivative of constant here is just going to be 0, so I'm going to add that. So now I need to set our first derivative to equal to 0 to find our critical point. So we have 3q squared minus 12q plus 15 is equal to 0. So you can see that this manifests a quadratic equation. But first, we can divide all through by 3. So we now have q squared minus 4q plus 5 is equal to 0. Oh, my bad, this question is actually incorrect. It's supposed to be c of q is equal to q cubed minus 6q squared minus 15q, not plus, then plus 20. Yeah, it's not supposed to be plus, so this is wrong. Sorry, it's supposed to be minus. So we first need to find our first derivative and set it to 0. So that's going to be 3q squared minus 12q minus 15. Then we set it to equal 0. So first we can divide all through by 3. So we have q squared minus 4q minus 5 is equal to 0. So now we can factorize. So we have minus 5. We can factorize this. We have 1 and 5, or plus 1 and minus 5. Because plus 1 times minus 5 is minus 5, and plus 1 minus 5 is just minus 4. So we have q squared plus q minus 5q minus 5 is equal to 0. So we can factor out to our q. We have q, open bracket, q plus 1 minus 5, open bracket, q plus 1, that's equal to 0. So we have q minus 5 and q plus 1 equal to 0. So know that q is equal to 5 and q is equal to minus 1. So how do we know? So we have our q to equal 5 and q equals minus 1. So we know that quantity can never equal 0. So this is a cost function and q is quantity. Quantity can never equal minus 1 rather. So we can never have negative quantity. So our candidate is obviously 5. So we're going to plug in 5 into the original function. So we have c for 5 is going to be 5 cubed minus 6 times 5 squared minus 15 times 5 then plus 20. So c of 5 is just going to be 5 times 5 times 5 is 125 minus 6 times 5 squared, that's 6 times 25, then minus 15 times 5, that's going to be 75 and plus 20. So our c of 5 is just going to be 125 minus 6 times 20, that's 120, 6 times 5, that's 30, that's going to be 150 minus 75 plus 20. So 125 plus 20, that's 145 minus 225, because minus 150 minus 75 is just 225. So we have our value to be so yeah, that's just going to be minus 80. That means the lowest possible cost that this firm can incur is the cost of minus 80. Let's say this is naira, minus 80 naira. So this is the lowest cost that the firm can minimize, provided you produce at a quantity of 5, that's an output of 5. So this is the lowest cost they could possibly incur. So yeah, that's basically how we optimize the function. So I'm going to make a short to explain why that rule stands, that f double prime of a is greater than 0, then the point is the minimum point, and if f double prime of a is less than 0, then the point is the maximum point. I'm going to make it short to explain the logic or the intuition of the mathematics behind it. So thank you for watching.